Okay, so I just want to look at solving equations graphically. So basically, we'll start off and I just want to look at these two curves. You got y equals x squared and you got y equals x plus 2. Now, if you sketch those two, y equals x squared looks like this, and y equals x plus 2 is y equals x is a 45-degree line, and then you go up to 2. So the points of intersection there, like if you had those x values, they will be the solution to the following equation. Like if you look at this and you solved it algebraically, then you'd be making x squared, you put x squared in place of the y, equals x plus 2. And then you move it to the other side, so you got x squared minus x minus 2 equals 0. So then you factorise it, so you get x minus 2, x plus 1 equals 0. So you end up with x is 2 and minus 1. So that's minus 1 and 2. So the actual solution to that equation is the same as the points of intersection of those two curves. So the concept that you just need to get here, that if you have two curves, y equals f of x and y equals g of x, and say that was y equals f of x, and then y equals g of x looks like, say this is y equals g of x. Then the x values that form the solution to that equation, say a and b, so x equals a and x equals b, are the solutions to the equation when f of x equals g of x. So when the two y values are equal to each other, and that's f of x minus g of x equals 0. So algebraically, you make these two things equal to each other. You bring it to the one side and you solve that, whether it's a quadratic or it's linear. You use your equation techniques to solve it. And the solution to that equation will be the same as if you sketched y equals f of x and you sketch y equals g of x and you found the point of intersection graphically. Okay. So say to solve y equals 2 to the x equals x plus 1 graphically, then, because there's no way to actually solve that algebraically, if you make y equal 2 to the x and y equal x plus 1, and then you sketch y equals 2 to the x, so it looks like that, and when x equals 0, y is 2 to the 0, which is 1, so it goes through there, and y equals x plus 1. Now I'm going to actually make that minus x plus 1, because then it will serve the purpose of what I want to show you, and it'll make it really nice and easy. So if you sketch y equals minus x plus 1, minus x has to go down there at 45 degrees, and then you've got to move it up 1. So it'll look like that. Then can you see that where it actually intersects will be when x equals 0 and y equals 1. So the actual solution to this equation will be x equals 0. Okay, so to solve this one graphically, so if you sketch y equals x plus 3 and you sketch y equals 6, so y equals x plus 3 would be shifted to the left to minus 3. That looks like that. And then y equals 6, if you put 6 there, going to go through there. So whatever those values are there, that will be the solution to those equations. So if you drew an accurate graph, you'd be able to read it off. We don't have one, so I'm just going to do the algebra thing just to get the point of intersection. So x plus 3 equals minus 6, so x is minus 9. And x plus 3 equals 6, so x is equal to 3. So it'll be 3 and minus 9, so it's x is minus 9, and x equals 3. So I just want to show you the relationship between when you solve it algebraically and when you do it graphically.